So this is another application of that sine angle sum formula or angle difference. You can go either way. We're going to use the angle sum like I have before. So the formula looks like this: a sine of x plus phi equals, and we have an a multiple, but normally it's just sine of x cosine of phi plus, because of the plus there, and then we switch to cosine of x sine of phi, and I see I forgot my a there because we have that extra a multiple there. And then we're going to compare that to the given expression. So the given expression has a 3.1 sine of x minus a 3.8 cosine of x. Oops. And so what we have here in our comparison is that the constant of 3 is going to line up with the a cosine phi, and the constant of negative 3.8 is going to line up with the a sine of phi. So when we put that together, we get a cosine of phi has to be the 3.1, so we have the sine of x matching there. And then we also get a sine of phi has to be negative 3.8. And then there's a few steps with the Pythagorean theorem, but we can skip down to the next part, which basically says that the 3.1 squared plus the negative 3.8 squared is equal to a squared. So a is ultimately going to be the square root of those guys right there, whatever that happens to be. So let's get a calculator on that. First, I'm just going to do the inside. So 3.1 squared plus 3.8 squared. And when you square negative, it becomes positive. So square root of 24.5. So let's say we call that little a. It's probably not going to be. Yeah, so that's kind of messy. So I could round there, but I'm going to keep it exact for a little bit. So 24.05. So then I get a is the square root of 24.05. So I haven't done any rounding yet. And then to get phi, we just solve for the cosine of phi there. So we would get cosine of phi is equal to 3.1 over that square root. And so phi is going to be the arc cosine. And again, the main reason I usually use the arc cosine is if you think about the arc sine and arc cosine, I should say red for the cosine. The arc cosine picks angles from 0 to pi. And then the arc sine picks angles from pi over 2 to negative pi over 2 or vice versa. And I just like to have positive angles when possible. And so the arc cosine gives me a wider range of positive angles to work with. So I usually use that one. And we'll see later in the course that that's beneficial in some other cases. So then phi is the arc cosine of this crazy number. And so as far as the min and the max go, I now know that this function right here can be rewritten to be the one I just created with a and phi. So a is the square root of 24.05 times the sine of x plus that angle, and I'm just going to call that angle phi for now. And phi again is this thing right here. So what do we know about the graph of this function right here? Well, since there's no plus anything on the outside, then the midline of this function is y equals 0. And we also know, because of this multiple out there, that the amplitude of this function is a equals the square root of 24.05. So if we think about the graph of that, and then it shifted, right? So forget about the shift for a minute, just think about the midline, y equals 0. And this is just a wave passing through that midline. And if we want to know what the max is, well, that's the amplitude. The max up here is that value, square root of 24.05. And the min down here, since we started at 0, would have to be the negative version of that, 24.05. And it turns out the shift really doesn't affect the max and the min. They're always where they are. So we get the answers. A from this is our answer. Square root of 24.05. And when I clicked on the box, it said I could type an expression or a decimal. So double check that. Yeah, so I could enter a mathematical expression. So I could say the max is the square root of 24.05, no rounding involved. Or I could go with the decimal version, because it does say decimals are allowed right there underneath. And the decimal version was 4.9041 to 4 decimal places. What did it say? Accurate to 4 decimal places. Yeah, so I go 4.9041, but for the minutes negative 4.9041, and the decimal version, at least that accurate or the exact answer should be acceptable there. Nice. So it is pretty cool that if we have a sum or difference of a sine and a cosine, that we can always rewrite it as a simple sine function. Well, not that simple, but a single sine function. How about that?